is called a horizontal asymptote. Horizontal asymptotes are a little bit trickier to figure out. We have some rules we have to learn in order to find a horizontal asymptote. And there's kind of 3 rules that go with a horizontal asymptote. Do I need to describe that that it's horizontal, or does that make sense that it's going to be horizontal? Okay. There's 2 situations that will make your horizontal asymptote horizontal. And then there's another situation where instead of having a horizontal asymptote, it'll actually have an oblique asymptote. And an oblique asymptote means that it's either diagonal, or sometimes it can even be a weird shape like a parabola. Yeah. Okay. And although I guess I was technically told one time that a parabolic asymptote wouldn't technically be called an oblique asymptote, it would have some other fancier name that is beyond the scope of this class. So we just call it an oblique asymptote and learn how to find it, and that's all that matters. Okay, so for horizontal asymptotes, there are 3 rules. Well, for horizontal and oblique asymptotes, there are 3 rules. Okay? Rule number 1. Remember how we learned about degree last chapter? And remember how we learned that, I just lost my train of thought. We learned what degree is. Oh, and just barely, we just learned that a rational function is just 2 polynomial functions, right? So the numerator is one polynomial with a degree, and the denominator is a different polynomial with a degree, right? Okay, so if the degree of the numerator is less than the degree of the denominator, then asymptote, there's an asymptote at y equals 0. So just at the axis. Sorry, I guess you couldn't see the whole thing. Forgive me. If the degree of the numerator is less than the degree of the denominator, then there's an asymptote. I kind of wrote that bad. There's an asymptote at y equals 0, no matter what. Okay. Rule 2. If the degrees of numerator and denominator, is it okay if I abbreviate them, are equal, then the horizontal asymptote is at y equals, and this is tricky to explain. It's easy to show and it's not hard to find, but it's the leading coefficients of the of the top polynomial and the bottom polynomial. So I'm just going to call it the leading coefficients, and then when you see some examples, it'll make more sense. Okay, sorry, I think I'm writing too small and too far, so I can't even zoom it in. I'm kind of off today. Okay, the 3rd rule is, what do you think? We have a pattern going on here. Degree of the top is less than the bottom. Degrees are equal. What do you think rule 3 is going to be? If the degree of the numerator is greater than the denominator, then the asymptote is oblique, and is found by long division. If the degree of the numerator is greater than the denominator, then the asymptote is oblique. and is found by doing long division. Okay, we need to do some examples. Okay, find the horizontal and oblique asymptotes. Let me just throw a bunch of possibilities at you. Let's see. How about f of x equals 8x squared minus x plus 2 over 4x squared minus 1. G of x equals x minus 12 over 4x squared plus x plus 1, and h of x equals 3x to the 4th minus x squared over x cubed minus x squared plus 1. Okay. So one at a time, let's see which rule they apply to and find the asymptotes. So, example number, should I just renumber them again, or did we leave off at a certain number previously? I'll just renumber them. I'll just call them 1, 2, and 3. It's all good. Okay. What's the degree? Degree of the numerator? 2, right? What's the degree of the denominator? 2. Tyson said they're the same. So this is rule number what? This is rule 2, same degree. So here's the one that I said is hard to explain but easy to find. The asymptote would be y equals, and it's what we call the leading coefficients. So the coefficients are the numbers next to the x's, but it's just the numbers on the highest two exponents. So you have to write them in order, so it's just the 8 and the 4. So we go 8 divided by 4. And so what's the horizontal asymptote going to be? Y equals 2. See how easy that is, but hard to explain, but easy to do? You just make sure that these are in order, descending order, so that the leading terms are just right there, and there's your answer. Yeah. Sound effects are important. Okay. Next. What's the issue on the next one? This is actually rule 1. Did you say that? The degree of the numerator is smaller than the degree of the denominator, yes? Degree 1 is less than degree 2. The asymptote is y equals 2 because it's a horizontal line. So you must have the x equals to tell you it's a vertical line, and the y equals to tell you it's a horizontal line. Just like I was picky when we did axis of symmetry, and it was x equals that axis of symmetry, right? Because it's a line. Okay. This one, what's the rule? Tyson's got it. I want to hear the rest of you. What's the... There you go. Okay. There's probably some vertical asymptotes, but that would be the only horizontal one. There's always only one horizontal or oblique. Yeah. Okay. Then the last one is rule what? Rule 3, of course, because we have degree 4, which is greater than degree 3. So there is no horizontal asymptote. Instead, it's oblique, and we have to do polynomial long division. So we go x cubed minus x squared plus 0x plus 1 divided into 3x to the 4th plus 0x cubed minus x squared plus 0x plus 1. Now the good news is that the remainder doesn't matter at all. So just a little side note, remainder, we're just going to ignore any remainder we might get, okay? multiply x cubed by to get 3x to the fourth? What do I multiply x cubed by to get 3x to the fourth? 3x. Okay, so now I go 3x times x cubed is 3x to the fourth. 3x times negative x squared is negative 3x cubed. 3x times 0 is 0x. 3x times 1 is 3x. Draw the line, change the sign. What does that mean? We have to subtract these. Don't forget that you have to subtract them. So it's actually a 3 minus 3, which is 0. And a 0 minus a negative 3 is a positive 3. And a negative 1 plus a 0 is a negative 1. And a 0 minus a 3x. And then we bring down the 1, right? Okay. Next, what do I multiply x cubed by to get 3x cubed? What do I multiply x cubed by to get 3x cubed? Plus 3. Did I do something wrong somewhere? When you do long division, you have to subtract. So I wrote that right there. Subtract. 3 minus 3 is 0. 0 minus a negative 3 is positive 3. Negative 1 minus 0 is negative 1. And 0 minus 3 is negative 3.
Yeah, when 0 minus negative 3 is negative 3.
But this is negative right here. So it's a positive 3x times a negative x squared is a negative 3x cubed. And then when you do long division, you subtract. So 0 minus a negative 3 is positive 3. Okay, now if I were to keep going, it would just lead to my remainder, right? Well, let's go ahead. Okay, so 3 times 3x cubed, you don't really have to keep going, but anyway, 3 times negative x is negative 3x squared. 3 times 0 is 0. 3 times 1 is 3. So at this point, this would cancel, and so we would just end up with a remainder. Okay? Because x cubed does not divide into x squared, correct? X cubed cannot divide into an x squared, so this is the remainder. That's the remainder, but what do we do with it? We ignore it. Where's our answer? The answer's right here. So the oblique asymptote is y equals 3x plus 3, which is a line that crosses through the 3 at the y-axis. 3 is the y-intercept, and 3 is the slope.